like SEIM, SOC, escalation of cyber events, detecting network-based attacks, etc. And today's session will be taken by Shri Shiv Kumar Kataria sir from Siemens. He's a senior key expert and having 17 years of experience. He also took our previous session. Shiv sir, you may start the session, sir.
Okay, yeah. You. Sharing my screen. My screen is visible, right?
Yes, sir.
Okay, so welcome again, everyone. We are meeting after the Friday's call where we discuss the identity function. And today we'll be talking about the detection function. And the objective of the identity function is to first identify the asset that we are having and then use that information to enumerate the security issues that might be there in terms of vulnerability assessment and penetration testing. We discussed the active and passive type of vulnerability assessment and the user management through authentication and authorization. And we briefly discussed a little bit more about the overall management of risk with these assets. And today we will be specifically focusing the next uh, part of the cybersecurity framework. So we are here today. Once we discussed this identity, we are now talking about this detection function. Let me take my exit line. Yeah. So we are talking specifically now on this particular part today. And the agenda for today's discussion is to understand the technologies like intrusion detection and intrusion prevention systems. And then we'll be discussing about detecting the network-based attack, some host-based attack, which is also called as endpoint intrusion detection. And we'll briefly discuss about the Siemens SOC solutions and finally about the escalation of cyber events, what we should do when we identify an event in the grid or substation. So at the end of the session, you will be able to understand the IDS and IPS, their differences, and how different type of IDS and IPS look like. Also, what is the difference between SIEM and SOC? And finally, the actions that you might need to take during an incident. So like last session, we'll be first finishing the slide, and at the end, we might take up some questions. Okay, so let's start with the intrusion detection system. So what does this intrusion detection system means basically? So as the name suggests, it detects the intrusions into our network or systems. So this could be either monitoring the network or monitoring the system, analyzing that, and then identifying if there is unauthorized or malicious activity happening uh, at both the planes, network or the system plane. Generally, the goal of IDS is to identify and alert the user about any security breach, potential attack, or some anomaly which is there in the real-time environment. So IDS are generally would be useful in terms of identifying the security threats, detecting some known attacks, and also some unusual behaviors. In next slide, we will be seeing the different types of IDS and how they detect it. But for now, the capability of IDS is to be able to detect the attacks based on the behavior pattern as well as signature pattern. I hope you must have gone through the anti-malware solution so far as well. So generally anti-malware solution and IDS solutions work on same methodology. They either detect it through some signatures that are hard-coded in the engine, or they could also detect based on some behaviors which are learned by the malware researchers, or they can also work on potential vulnerabilities that are there into the database. So if you look in terms of who are the providers of IDS, generally you must have heard of these names like Nozomi, Clarity, Darktrace, uh, Cisco, Forescout, Armis. These are the vendors which provide the commercial solutions, but there are few open source solutions as well available like Snort and Suricata. And these are pretty easy to use. You can configure them on network side and put up some signature, and they would be pretty well be able to detect the signatures of anomalous behavior. So there are large number of signatures already inbuilt in Snort. You just use those by default signature, and they would be pretty much do the work of not only the IT side of the word, but as well as the OT side of word as well. It has signatures of DNP3 inbuilt. It has signatures of Modbus as well inbuilt. So they are very useful to detect the signatures. Now coming to the types of IDS, there are generally two different type of IDS. One is the host IDS, which can also be called as endpoint uh, intrusion detection system. And then the other one is the network-based intrusion detection system. So as the name suggests, the main difference between these two is the host IDS works on the endpoint. In our environment, it could be an operator station, it could be an engineering station, it could be the server, it could be a seek and pass server, it could be a service PC or remote desktop. It could also be an Active Directory domain controller. So all those systems which are pretty much running on the Windows environment or Linux environment, there you can deploy a host-based intrusion detection system. And what they do is they read into the log files, they read into the changes in the system, they also read the system registries and detect the anomalous behavior based on the understanding of typical malicious behavior. So these typical malicious behavior are already understood. You can actually find it online available at various threat sources, what they generally do and how they will deploy. At this point, the knowledge that we had discussed in the last session of identify function of understanding the threat through the MITRE attack framework is also useful. So what we have seen is the techniques that is being used by the malicious actor to attack a system. Those techniques can also be used in the intrusion detection system to identify a threat in your environment. And that's why the more emphasis on deploying a successful cybersecurity program is to understand the threats to that particular sector. And MITRE attack is one of the framework that is really very helpful to understand those. On network side, IDSs are capable of detecting any suspicious and malicious activity. It could be either through unreasonably large payloads or the changing the values in the packet or spoofing the packet, and maybe packet coming from some blocked IP addresses or some block protocol. All these kind of signatures can be programmed into an IDS at the network side, and it would be very well be able to uh, detect those. So they can be deployed at the network perimeter, or they can also be deployed between network zones. And IDS are pretty useful in specifically in industrial control system environment, since they don't interfere with the regular functions. They work on the detection mechanism. They don't work on anything active process generally. And since we don't want our operations to hamper, we can use them very well in industrial control systems. And two of the framework which are available or open source is Snort and Suricata. Though we will not be discussing them in today's lecture, but they are very good candidate for deploying something uh, by yourself without requiring any additional help. Yeah, so let's talk about the network-based IDS. The main characteristics of network-based IDS is they analyze the traffic in real time, and generally it happens out of the band through either using a network tap device or using a mirror port into the network switches. In next slide, we will be seeing what network port, mirror port basically means, but they are generally deployed on the mirror traffic, not only not on directly moving traffic as such. They detect the patterns and anomalies in the network traffic, and they can be deployed at various key points where you are really interested to know that, okay, these are my incoming traffic points from untrusted source or beyond my secure substation boundaries or my control center boundaries. All these points are a good candidate to deploy a intrusion detection system in the network. They generally provide insights on not only the external threats, but also the internal threats, because you can actually configure the rule both ways, the egress rule and ingress rule. Egress rule basically means the traffic that is flowing out of your control system or substation. And ingress rule basically means anything which is coming from external or to internal. And they might utilize either a signature-based detection, or they can also use the anomaly-based detection method as well. As we discussed in the previous slide, there are a pretty sophisticated solution available on anomaly-based detection engines like Clarity, Nozomi, TenableOT, Darktrace, and then OTSEC. These different vendors are having very robust solution which work on anomaly-based mechanism of intrusion detection. Now, a bit of networking lesson here is like we required to configure span or mirror port to be able to use the intrusion detection system in our switches. And generally, all the managed switch do provide this capability to configure the mirror ports. And the mirror port, what basically does is whatever traffic is flowing between these network ports, it will copy the same traffic and then forward it to one of the network ports of our choice. And we put our IDS device, network IDS, in that particular port, and it will be reading through the packets and will tell, okay, what is going on the network. So this is the example of network port monitoring. And what you're seeing is another example of deploying an IDS by one of the vendor Nozomi at these points of network traffic monitoring. So the switch is having this monitoring capability, mirroring capability, port mirroring capability, and then you are putting this Nozomi guardian device to detect the network traffic. Sometimes you might require to deploy it at the different layers as well. Like you might be interested to deploy it at this particular layer of access switch. So that is also possible with the mirror porting. So this is another example of using it in our grid system or substation system. We might deploy it at the process level. We can deploy it at the bay level and substation as well as the control center level. All of them can be used to mirror the traffic using a span port. We can put a sensor there, IDS sensor, or just put a mirror port there and bring that into one single appliance. What you're seeing here is a bigger appliance. You bring all the traffic at this appliance, and then you put your network intrusion detection system. So depending on the network, there could be n number of combination, either putting them at the one place or putting different sensors at different location and then bringing the analyzed information to one single place. So this is true specifically for the anomaly detection based IDS. If we are willing to put our open source IDS, then this architecture is holds very good for those kind of situations. You mirror the traffic, bring it to one single network device, and there you can put your IDS appliance. So there are different techniques on which these IDS basically works. I mentioned two of them is signature-based, anomaly-based, but there is another one which is behavior-based or heuristic-based. Signature-based are basically having some rules configured already, depending on the provider of the IDS. They would have their own rules, but the rules are generally also available on SNOT website, which is an open source IDS. And what it will do is it will either look for those protocols, those IP addresses, or it can also detect those strings in the network traffic as well to give us the uh, intrusion alert at the network side. Anomaly-based engines are generally based on detecting the anomaly. So since the amount of data is very large, they typically use artificial intelligence-based techniques to detect those anomalies. There are different techniques like local outlier function and all those things in artificial intelligence and machine learning. And they basically would be checking, okay, which particular pattern is not falling into the cluster of patterns that we have initially recognized. And based on that, it will be able to uh, detect the anomaly in the network. The third one is based on the behavior. So it again comes from the MITRE Tech framework. There are a number of techniques, and these techniques can be then used to make heuristic pattern. Okay, the malware first downloads a file and then it will go and change those registry. So those kind of things can be programmed into a heuristic based NIDS, and then the NIDS will be detecting those issues in the system, in the network. So how does this NIDS works? They basically monitor the traffic passively, and then they first do the asset discovery based on the header of the packet, and sometimes uh, based on the type of asset itself, they would be able to tell, okay, this asset, since it is an old asset, it is running this particular version of firmware, there are these issues available in this particular asset. They also use the same asset information to give us vulnerability insights, and also some detection of the threats. Multiple packets can be read, and then some threat information can be generated. And it is very important that we do a baselining when we are deploying IDSs. And this typically happens during the learning period, specifically these commercial solutions which are working on anomaly-based detection. They will first understand the system for a few days, and after that, they will be working on the operations mode, uh, learning from the baseline that we have set up. They will generate a number of alerts based on anomalous behavior. And sometimes, optionally, these solutions can also do some active probing to understand the device behavior. Okay, so how do NIDS actually work is deploying the effective IDS involves several stages, and it is very important to ensure that the performance of threat detection is accurate and we have minimal false positive in the network. Since they are based on different signatures and working on passive networks, there may very well be some false positives. Like sometimes the packet which is coming from a different network communication, it might say that, okay, this is having signatures of some different protocols. I have seen those kind of packets in the network. So we need to baseline those different packets and uh, document the false positive so that when they repeat, we are sure and we are having confidence that, okay, these packets may be neglected. Uh, there is nothing else that needs to be done on that. So basically, what we need to do is we should start with the asset identification that we have done in the identity function. Then we put these anomaly detection systems into learning mode. We do then baselining. Then after that, we do go into detection mode. And after that, we fine tune our learnings and put into an operations or monitoring mode. So that was about network-based IDS. Then we have similarly some host-based IDS, or we can also call them as endpoint-based IDS. They work on individual host systems, and they read into log files, changes in the files, some process activities, some user actions, and based on that, tell, okay, whether the behavior is intrusive or it's regular. They also detect unauthorized accesses, some malware execution, as well as configuration changes of the file, and they provide insight into threats and system level compromises. So the typical example could be Clarity, which basically not only does this network-based detection, but they have the module called Clarity Edge, and this edge can be used to detect the host space intrusion as well. But now Microsoft's uh, Defender itself also comes with inbuilt IDS's capability. So we can also configure or use this Microsoft Defender as well. Host IDS works on typically collecting the data, monitoring the system events, analyzing them based on some rules or some anomaly. Then it will generate some alert, and based on those alerts, it will also generate some response or mitigation mechanism. And finally, it will log into your log server. So during the log collection stage, the agents or sensors are installed in the individual host system, and these agents will be then collecting different types of data or events from the system. You must have seen the Qualys Guard agent or maybe some McAfee agent installed in the system sometimes. So these agents are basically working as host IDS system, and they will typically will be collecting these logs from the system and also reading into the actions that user are taking, like changing a file, deleting a file, or if there is a process hijacking happening, one particular process is calling another process. So these are example of typical heuristic based intrusion detection. They also read typically the system registries, the type of connections that but the particular system is having, and based on the baseline that we had set, it will take the actions of uh, detecting or just passing it through the network. During the event monitoring stage, the agents also will continuously read into the system events. Typically in Windows, we have Windows events available, and these events are of different type, like somebody executing a process, the user logging in, the actions that the user is taking, and as well as some network connections that might be happening. All those events are typically logged into Windows system, but sometimes Windows collecting these Windows system logs may not be very straightforward because they don't work on syslog protocol. So we might require to install a third-party syslog application to forward this log to some centralized server as well. After the event monitoring, the next step is to analyze them. And during this stage, the collected data is normalized. Like this example I had given, that Windows log getting normalized into syslog format to establish the baseline of normal behavior as well as the anomalous behavior. It also monitors different things like how much resource is used, the behavior of user, and the communication patterns. So after analysis, we have this detection function, which is either based on rule or some anomaly. Rules are again is hard-coded strings, which could be like the source address, destination, source port, destination port, kind of thing. And the anomaly is basically the outliers in the patterns of the system functioning. So one of the example is like, let's say a system generally works on 9 a.m. to 5 p.m. And if something of the sort like configuration change or firmware download is happening at 8 p.m., this is an anomalous behavior. So system will then see it, okay, and then put it into an configuration change alert kind of thing. So you don't expect your system will be doing some firmware download or configuration change in the out of working hours. Then we have a generation of the alert based on these two rules. The IDS will be generating these alerts, and sometimes the IDS will also give the capability to forward these logs into SIM solutions. And SIM solutions are typically used to monitor the overall security information within a particular system. It could be either your substation, it could be either your control center. You can pretty much put the same solution at both the levels. And after this, there is some response and mitigation function based on the decision that we'll take. And finally, this will be logged for further use. Sometimes this logging is useful into maybe doing analysis several months later as well. We might want to correlate, okay, this particular thing is happening today. Is there a precedent of this particular kind of activity in the past as well? So logging could be helpful in those forensic analysis. The advantage of host-based intrusion detection is basically monitors the changes into system files and configurations. It helps in identifying unauthorized modification. It can also detect the insider threats uh, because it continuously monitors the user actions. And the targeted attack can also be detected from the HIDS solutions. And since it's working on the user activity, it gives a very, very granular visibility into the system. And uh, sometimes if we are using anomalous intrusion detection system, there is possibility that we would be able to detect some unknown threats as well, because they are based on the behavior or some anomaly that was classified as malicious behavior, though we might not have those kind of things available as a rule-based or signature-based IDS. In some cases, IDS also can take some action in terms of quarantining the system or preventing lateral movement of attack, but these are the special kind of IDS. Generally, they are non-intrusive. They just detect the attack and stop at that place. Now we'll move to intrusion prevention system, but before that, be very cautious about using intrusion prevention system. They are actually uh, works on very, very intrusive manner. They work in line with the network and they take action on the traffic. Unlike the IDS, which just detects it, it all actually prevents the network traffic coming in. And pretty often, if we don't have the knowledge of the kind of traffic we require, it might hamper the availability of the system as well. So IPS operates on, again, analyzing the network traffic, but it goes beyond the capability of IDS by actively preventing and mitigating the security threats in real time. It can be useful to implement them as the network with perimeter, where your outside world communication is actually starting. It's generally not used inside your secure network boundaries. Let's say the example of your substation to control center communication. Their IPSs are not used because we don't know which particular traffic it might detect as intrusive and then block that particular traffic. So it's a very useful in terms of giving an additional layer of defense by blocking the network traffic. And the best place to put it is after the firewall at your perimeter device, because the firewall will first filter the traffic based on rules, and only filtered traffic will come to IPS to analyze further and then block the malicious traffic. If we put it before the firewall, then all the traffic will then come to IPS and it will get flooded with the information, which is typically not necessary for an IPS to. And IPS are generally put up in conjunction with the other security appliances like the firewall, which I mentioned just now, or the IDSs as well, to first log and then prevent, so you have the understanding of what kind of traffic was flowing in the network. So it works with the starting with the traffic instruction, and then there could be three different type of IPS: anomaly based, signature based, and behavior based, similar to IDS. They filter the traffic and block it, and they also alert the user of what they have basically blocks in the network. And finally, they will be logging the action that is taken. Uh, Pretty much the same functionality, first inspecting the network traffic by analyzing the packets. And they also utilize some deep packet inspection technique and understanding the various points of intrusion that could happen at the network side. Uh, we can put it at network perimeter, within segments, or sometimes directly on the host as well. Signature-based detection is a technique where we hard code the patterns, the vulnerabilities, and malware signatures in the detection engine. Anomaly-based system is where we put the baseline of normal versus abnormal behavior, and behavior-based is typically understanding the uh, patterns which could exist in the malicious behavior, and whenever there is a deviation from those patterns, it will detect those activities. Then during the traffic filtering and blocking stage, it will simply take the action of blocking the traffic, and that's where the main difference between IDS and IPS exists. It actively prevents the traffic, which might have a malicious threat or alert being detected by the IPS engine. In the response and mitigation side, it will drop the packet. It might reset the connection. It might generate an alert for the packet or neutralize that. And then in the next stage, which is generating the alert, it will log that information, or maybe it would forward it to the SIM solution as well. Finally, it will log this. This logging is pretty important to understand the activities which had happened in the history of one particular network action that our system has taken. The benefit of IPS is it provides real-time protection against both known and unknown threats. It automatically blocks threats and also reduce the window of exposure since the malicious traffic is being dropped. It can be fine-tuned based on the learnings to reduce the number of false positives in the network. It is very effective against zero-day attacks and advanced persistent threat as well, since it is continuously monitors those behavior at the network. Yeah, so now we have finished this IDS and IPS part. We'll move to the SIM and SOC part of our discussion. At this point, if you have any questions on IDS, IPS, we can discuss it.
So I have a question.
Yeah.
So if we use IDS and IPS both, like like you said, we can use IPS along with IDS. So what will be the advantage of using IDS in that case? And secondly, how do we place, like you said, IPS should be placed after firewall. Then how do we place like firewall, IDS and IPS?
So just come back to the architecture. So we have something to discuss about. This architecture is visible to you, right? Hello.
Yes, sir.
Yeah, it's visible.
Yeah. So your question is why don't we use IDS and IPS both at one place, right? So the main difference between IDS IPS is as we discussed, is IDS basically detects the malicious activity. IPS will prevent the activity. And since we don't know what kind of activity is important for us, if we are 100% sure that, okay, this is a malicious activity, we should take action on, then we can put the IPS as well. But since you must have read into initial 1 or 2 lectures of this course, the focus on industrial control system is more on availability and integrity of the system rather than the confidentiality of the system. So that is the reason we don't use IPS at the production side of industrial control system. We only use IPS where we are giving access to outside world. A very good candidate for deploying an IPS is your secure remote access. From remote access side, it is not hampering your operations. It is during the maintenance, or maybe you are just sharing some data with some outside untrusted network. If you have seen, okay, let me pull this document. There is a document available by Siemens. It's called CCAM Ciprotech Secure Substation Guide. So in the document, I written this document few years ago, and we had discussed this in length, that what are the right candidate for putting an IDS solution and what is the right candidate for IPS solution. So maybe I'll just put the link in this chat box, and you can actually go through this document as well.
Okay, so just one thing, like IPS can be configured as IDS also, no? So I was asking
Yeah,
that
so
can you
you are
add
talking
IDS
about
also?
a device which works a unified threat management device. And what we are
Yes,
doing
sir.
here is we are learning the conceptual part. So I know you are talking about maybe a Fortinet device that can be configured as either an IDS or an IPS. And that's where in this document, you specifically will be uh, at one of the point I have specifically mentioned that only configure the detection function, don't enable the prevention function in this device. It's very important not to use IPS at the production site, only use into your uh, insecure network communication. So I have put up in the chat box, you can go through this document maybe later, and it has that
Oh,
information already available. It has also given some configuration diagram, how to configure your secure remote access and how to configure your solution like SIM and SOAK, what kind of Windows system you should buy when you're buying, because there are two different kind of solution typically available. One is with the short-term support, one is with the long-term support. And we really want to ensure that our system works for maybe 10 years or 15 years. So it is always advisable to use a long-term support system. So I'm just scrolling. Maybe I'll find out the specific paragraph where I will mention, and you can see particular. Is it clear now that why we don't want to use IPS?
yes, sir. Thank you, sir. Thank you, sir.
Okay, maybe later on I'll just see
Shivji,
here.
hi, Islam here. So basically,
Hmm.
somewhere I read that Nozomi also has IDS, I think.
Yeah, so
So,
these are typically anomaly detection devices. They work on the IDS philosophy,
okay.
and all of them are same. They would be sitting on the passive network and giving you alert of malicious activity based on deep packet inspection.
Oh, sure.
So they
And
call them they
yeah,
call
sorry.
themselves as industrial anomaly detection thing, but they are typically an advanced IDS with three different capabilities. They first give the asset identification, second, they give the vulnerability identification, and third is the anomaly or say risk identification of particular device. These are the three major functions these solutions do. And all of these three things are basically done through deep packet inspection.
Okay,
Yeah.
sure. Thanks.
Any other question? Shall we move ahead with the next topic? All right. So at this point, what we understand is what is IDS and what is IPS. And uh, you might think by now that, okay, I have put up the IDS now, and I'm having, let's say, 20 different substations, and they are all having connection to my control center. At the control center level, I want to know what is the health of my substations, right? So for such things, we have solutions like SIM and SOAK. All the security related information you can actually forward to the SIM, and then later on it can be forwarded to SOAK. And one prime difference between SIM and SOAK is SIM is a smaller solution that works on some set defined pattern of security logging. SOAK is a bigger solution which correlate information from multiple sources. That's why it's called Security Operations Center. It would have capability of detection, it would have capability of analyzing, it would have capability of correlating, it would have capability of normalizing log from different sources, and uh, taking in threat intel from multiple sources, and based on that, it will take those decisions of alerting you about the security issues. So SIM basically stands for Security Information and Event Management, and it has 4 different functions. It basically collects the log and stores them, it analyzes, and finally generates reporting based on that. You might have heard about some solutions like McAfee SIEM solution or QRadar kind of solution. And Splunk is another example. They can be used your SIEM solution as well as your SOC solutions if you put the capabilities of correlating with different SIEM. So they first will receive the log from multiple devices, then they will make it storage of those logs into a scalable and secure data management system. Finally, they will analyze that through different threat intelligence, the anomaly detection engine, and then correlating it with different sources. Finally, they will generate the alert of comprehensive reporting. On the other side, Security Operations Center is dedicated. It will have the SIEM solutions as well as multiple other solutions, and what you have is the capability of monitoring, detecting, and responding to a security event. And it's more of a work of a team rather than the tool themselves, because you require the capability of not only detecting these issues, but also the capability of analyzing them. There is a fuse coordination that is required between your security monitoring team as well as incident response and threat mitigation team as well. The typical benefit of a SOC is it helps in rapidly detecting and responding to threats. It also helps in proactively threat hunting and analysis. Since we are getting the threat feed from multiple sources, the capability really help us to basically be proactive in terms of taking some action when there is some malicious activity happening. And since we have the capability to correlate it from multiple different sources, so let's say you identify one of the threat at one of the location, you are immediately alerted about the different location that might have similar kind of network capabilities, different capabilities already. And you would be proactive to take those actions to secure your systems at different locations. Since it has the proactive mechanism and different tools, it helps us in meeting up the compliance and reporting requirement of different organizations. Like you might see now, certain have given the guideline to maintain the log for certain number of things. Also, when you have some incident, NCIATC might come and they might ask to security logs. So these solutions will be really helpful to immediately give them response, since you have already available that information at one place. So what's the difference between SIEM and SOC? SIEM is a technology solution that collects, aggregates, analyzes, and correlates the security-related data from various sources. It could be organization's IT or OT environment. And the focus of SIEM solution is data collection, analysis, and detection, whereas SOC is a dedicated facility or team responsible for monitoring, detecting, analyzing, and responding to it. At the same time, mitigating the security threats and incidents. So you can think it as a combination of technology and people, whereas SIEM is just only the technology part of it. SOC is basically a dedicated team, and it focuses on the human element more rather than the technological element, because human might have that understanding, that experience, the skill to investigate, analyze, logically evaluate, and coordinate within different department of the organization. So that's briefly about SIEM and SOC. Now we will move to the last segment of today's discussion, which is about what should we do when we have a cyber event. Before moving forward, do we have any question on SIEM and SOC?
Sir, can you please explain what is syslogs?
So syslog is a type of logging protocol, and there are 7 different levels of logging in syslog, and they are pretty much defined. So if you go to Windows, you will see event logs available here. They would be in the Windows event logging format, and syslog is a format which is generally used by the network devices. So basically, you can think syslog as a type of logging protocol. That what kind of log it will have. It will first have the timestamp of the log, then it will have what kind of log it is. Then, as I mentioned, there are 7 different severity level mentioned in the syslog format. It will have, okay, what kind of severity level this log is. Then it will have the information of that particular alerting mechanism. And since Windows does not have by default the syslog mechanism available, sometimes we need third-party tool like NSLog or some open source different syslog applications to capture the Windows logs and then convert them into syslog format, forward into a 6-log server. So it's just a protocol of logging system events.
Thank you. Thank you, sir.
Any other question? So cyber events, now we have understood identifying, we've understood detection, but what if there is something happens? What we need to focus? The cyber events is important to focus because once we have a detection capability available, not stop there, we need to also take some actions and then also understand what should we classify as a cyber event. It's basically a rapid and effective response to security events and which allow us to minimize the potential damage by preventing the further compromise to our system. So typically when I go to assessments, I ask this question that what will you do when you identify that, okay, one of the system is having some malicious behavior? And typical answer would be that we will unplug the power of the system. But that's not the way you should address a security event. You would really be interested to know what was the reason that the system was behaving maliciously. So for this, we need to know what could be different options to us, whom should we inform during such events, because the information that is there in the system is very critical to analyze the cause of that particular event. In one of the plant that I have visited, there was one X-ray machine, and this machine was crashing 2 times a week. And the typical assumption is since the machine is running on Windows XP, and maybe it is an issue of the OS, and the system is quite old, and the processor is not able to handle the traffic which is there. But when we went there and when we analyzed, this was not true. The assumption that the system is not able to hold the load is a myth because you have been using the system for so many years, and the system are designed to perform that particular activity. So what we had analyzed when we were doing the investigation is there was malware infection in the system. And because of the malware, the system was trying to do some lateral infection. And due to that lateral infection, it will generate loads of traffic. The traffic will basically make a denial of service on the network side, and the system will crash after this. So every time the crash will happen, the people at the plant will basically restore the system again. But it was when we have investigated the system, we identified, okay, it's not the issue of the OS of the hardware, it's basically the issue of the malware that is there. So it's important that we take right decisions when there is an event, and the teams should have clear-cut identified responsibility, very well communicated, very well documented, very well trained, and some people should also have the decision-making capability available to them that what kind of decisions will take when these kind of things are happening in our life. So immediately after this, I had kept this slide because it's very, very important to understand how our ICS attacks are different from the typical IT attack. A typical IT attack will have only stage 1 kind of thing, but a targeted ICS attack would have 2 different stages. The first stage is generally used to understand the system, design the command and control system, and get multiple persistent connection to the system. Whereas the stage 2 is the main stage where the malicious actor will take action. If you take example of the well-known Stuxnet attack, We know the attack has happened in 2010, but the earliest signatures of Stuxnet or the predecessor of Stuxnet are found as early as 2006 itself. And now it is very well established that for initial 1 or 2 year, let's say 2006 to 2008, they would have designed the version 1 of Stuxnet that was being used to first reconnaissance of this, use it, recce of the system, to understand what kind of devices they were using. You might know by now, I have seen the last week's content, and you must have gone through Stuxnet attack, that they have designed the malware with 7 different payloads, and 4 of them were 0 days. How did they design these 0 days? How did they come to know that they will be requiring these different kind of payloads? It's only after doing the initial hacking stage 1, and then during the weaponization phase, they designed these 7 different payloads. So that wherever the system is having this in the network, it will take the decision based on that. They have used the vulnerability of print spooler. They have used vulnerabilities in the network. They have used vulnerabilities at other Windows typical functionalities. Their main target was to reach to the industrial control system, which is running WinCC application, and then finally also be having the capability to change the configuration or the ladder logic through 2 different rootkits. So it was super advanced malware, but it very well had a very large period of a stage 1 attack. They designed their cyber intrusion through multiple exploits and installed it. And then in this particular case, though they did not have any persistent command and control system, but they have understood, okay, since it's a very, very air-gapped and secure facility, they need to have the capability to deliver the malware through some out-of-band techniques, like either delivering it through some pen drive or maybe some device that is being supplied to the plant. They might bug it and then supply it there. In stage 2, they will basically be testing their hypothesis and then finally taking the action in the execution of the malware, which would either modify the functioning of the plant or cause some devastating impact. So the actual attack that happened in 2010 was at this particular stage, the last stage of execution of ICS. Okay, so this is the typical workflow of escalation of cyber event. We start with initial detection through our IDS, IPS, and SIM solution. We then do assessment of and triaging what is happening there. We will go through each one of them, but at the high level, this is the workflow of escalation of a cyber event. Once you triage, then you will do initial response. Then you might escalate to level 1 support, level 2 support. You do a management notification. Then sometimes communication and coordination is also necessary to your internal departments, as well as if it is necessary, you might also want to notify the external agencies as well. And certain in India has very, very specific guidelines that even if some assessor is there at the, one of the critical infrastructure or other facilities, and if they get to know that there is an incident or an event, it is the responsibility of the assessor or auditor also to notify certain about that event, even though the organization might not bring it to the certain's notice. Then the incident response team kicks in. They do resolution of the issue, and the typical cycle of incident management is the 7 different stages, which is not part of this discussion today. But yeah, when we have incident response or management discussion, we might discuss the 7 different stages as well. And after that, when we take the review of what has gone wrong, what should have been done differently to mitigate such kind of risk in future, all this go into the post-incident review and documentation to make awareness training to the people which are responsible. So initial detection is through IDS, IPS, your SIM alerts, some manual monitoring as well by security analysts. Sometimes your regular solution might not help. So that's why we have frequent vulnerability assessment and penetration testing activities as well. If there is some new attack and is detected and it is not being detected by existing solutions, it's always good to have a third eye in our system through regular vulnerability assessment activities. Once these events are detected, let's say you got an alert that one of your system is having a malware on it. So the first thing that you will do is to inform your security team, and then they will do the assessment and triage why this alert is coming. Is there really a malware or is it a false positive? Typically, in the signature-based kind of alerts of IDS, you might find some false positive as well. I have seen recently in one of the analysis of event that we are doing that an IT protocol packet was having a DNP3 written in the string. And since it was written a DNP3 in the string, the system has alerted as a malicious packet. So these kind of things are basically false positive that does not require any specific action. Triage is very important to take the next step there to evaluate the severity, impact, and potential risk. And it requires the understanding of the nature of event as well as the categorizing them based on the incident management criteria. What kind of risk it is? It is a high risk, low risk, medium risk kind of thing. And based on this assessment, the security team will initiate the initial response, and this response would involve either isolating the system from the network to contain the threat or some implementing some predefined steps. And these predefined steps might involve taking some online backup of the system so that we can use this information for analyzing the threat on later stage. Once the initial response is done, then we will escalate it to level 1 support, which will be basically analyzing the event. If it's a complex event, we require the support of a level 1 team, which typically sits in SOC centers, and this could involve some analyst who would have experience on such kind of event handling or incident handling. If it's pretty much complex, then we go to level 2 support in SOC, and they would have a specialized skill to investigate more in depth about the particular event. They might then formulate some comprehensive plan to take next actions after that, take it forward from there. So at this moment, we should notify the management, the higher management, basically, not the plant level management, because they would get involved immediately after the stage 1 itself to apprise them about this risk, that this kind of attack that might pose, the impact that might be possible, because during the investigation stage, we've identified that, okay, it's a bigger incident, and this could have been repeated to different locations, so involvement of higher management with clear-cut defined responsibility and actions should be there. We should also provide a detailed assessment report at this stage. Sometimes it's not possible to do it in such less amount of time, so we might be interested to involve some external parties as well. And this report should typically involve the possible implications and recommended actions to the management as well. So once we inform the management, then the management might decide to inform within the departments, okay, this particular thing has happened, and then they might involve all the legal teams, IT team, compliance team, PR teams to decide what should be their plan of action to inform whether to general public or not. And 2 years ago, there was an attack on a company which produces aluminum, NOx hydro. And when the employee reached to the office in the morning, there was a big notification there that we would not be able to facilitate you inside the office today, and we will inform you in due course. So what happened is they had experienced a big attack, and they are not able to restore their system or provide the system access to their employees. And it went on for several days for them to actually get back to the normal operation for the people to work in in the plant. Yeah, so communication also involves external parties involvement. In India, it's the regulatory authorities like CERT, NCIPC. Sometimes, if we are a public entity, then I am aware of a few of the other agencies also get into the discussion. Sometimes maybe IB, Intelligence Bureau might also get into the discussion. Sometimes the Indian Cyber Coordination Center might also get into discussion to investigate even further. Like the event which has happened in Maharashtra a few years ago, there was multi-agency committee that was formed to investigate on this kind of incident. They really wanted to understand what has gone wrong at that moment of time. Parallelly, the incident response team will kick in. They will do analysis of the logs, they plan some appropriate action to the event, and these teams generally have experts from different domains who has in-depth understanding of taking actions on this incident and proper containment, as well as investigations of the activities that might have happened before that particular event. Finally, they will take some action in terms of resolving and recovering the system from that incident and restore the system to normal operations. This typically involves forensics, patching the vulnerability, and implementing additional security controls like additional countermeasures. And after that, all of this activity, there are some things that as post-incident review. This typically involves actions like documenting what has gone wrong and also uh, logging those things for future trainings and awareness of the people who are working on the security side. Yeah, so this is about cyber events. Any questions so far? Okay, so we don't have a question. So let me ask a question here. So this is the architecture that is available to us. And I would like to know that what is the right position to put the IDS in this architecture? Hello. Akshay, are you there?
Yes, sir, you are audible, sir. So
Yeah.
the participants may answer to sir's question. Uh, where to put the ideas in the OT architecture.
Probably below the firewall.
Okay, so we have firewall here. So you are suggesting that below the firewall?
Yes, we are saying IDS. Huh?
Yes, yes. Okay. So this is one location for your network IDS. That's very correct answer. But what if I want to get the information about the traffic that is flowing at layer 2? Would this traffic be visible to me here?
No,
After this router?
no.
Right? Yeah. So where should I put the IDS again?
After the router.
Yeah.
Correct. Okay. So I'll put it here. And one more we should be cautious about is what about your safety instrumented system?
Sir, can you please repeat? I couldn't hear.
Yeah, I was asking what about the safety instrumented system? Should we also monitor that?
No, that will know. Either host-based and network-based IDs can be used.
Yes, exactly. Yeah, that's SIS is also very important. It's super critical system because it is your go-to system when everything else fails. SIS is helpful to us. So we should generally include the SIS as your network detection or maybe host detection as well. So in this example, though it's not from grid, but it's a typical hierarchical architectures based on 5D model. And at this particular architecture, the point of IDS would be your SIS system or your SCADA system. Then at your site level control, you will be putting it below the firewall. And we might also put at the enterprise side of the network as well. So your enterprise level systems.
OT environments, sir. So what is the normal practice to have host-based IDS? Like you said, when we need to monitor the layer 2 traffic within the OT network.
Yes, it's a very good question. And typically, it depends on the kind of system. The new substation system that we typically configure, we put both. We put McAfee's host-based intelligent detection system as well. On the network side also we put it. But on the legacy systems, since we have really the resource constraint and the IDS, it will be reading into your system continuously. So it will require some resource. So there, we typically don't put the host-based, we put the network-based IDS through passive network monitoring. Does that answer your question?
Yes. One more thing I have to ask, like solutions available in market like NMS, syslog, SIEM, IPS IDS such a intrusion detection and prevention system. So is it something like having multiple systems of different makes? Does it make the system more complex, or there is one solution that fits, means kind of gives all kind of solutions to single network?
Okay, yeah. So typically, if your system is very robust and you want to ensure that I need to have backup of the backup. So when I was in NCIPC, we used to recommend that when you are using two firewalls, use two different brands. Don't use them of one single brand. Because if one of them is having vulnerability, then the other will save you. But if your system is, let's say, substation, and typically substation generally, though it's a very critical system, they will typically have 5 or 10 different assets in the hardware asset I'm talking about. Applications might be more. So it's good to use a single vendor application because you really don't want to complex your system. And anyway, since a grid level operator might have multiple systems from multiple vendors, they would have different varieties, and it becomes a huge pain for them to manage this multi-vendor environment. But depends on the complexity you want to introduce to your system based on your operational feasibility or operational convenience. Like how many different kind of vendor you want to introduce to your system. But now OEMs are very advanced in terms of bringing the solutions. Like if you say Siemens, they have substation level solutions for all kind of requirements. They have a specific solution for asset visibility, a specific solution for network visibility, and solutions like managed services or patch management. So similarly, if you put Clarity, they will also have something similar to that. Monogamy will have something similar to that.
Okay, one more thing, like right now concern is about network security, and when we are thinking of solutions, we are thinking that way also, like let's have a network based solution where one server would be there and will be giving policies or rules to the clients. Okay. So when we say host based or network based IDS, in the same manner we implement network based client server architecture of antivirus and all. So do we think in that way also, like say if server is there and one server policy changed by getting login to that particular application, say antivirus. So from one PC only, all the clients can be given that policy, which might the network or may stop detection of some kind of attack. So do we think like that also in terms of host based or network based any application selection?
Yeah, so this is again the example of your convenience, and yeah, that's how your host-based applications are currently working. You install the agent, and the agent is then communicating to your server. If this is a typical example of a Trellix solution by McAfee, that's how they do work. Or if it is any other vendor, they typically work on the same agent, whether it's Q agent or Card or CloudStrike, whosoever it is. You design the policy at one place and then you provision the policy. Similarly to your Active Directory domain controller, you create the policy and then if any system joins the domain, they will be following the same policy. So it's huge convenience. But the challenge here is in the legacy system, they might not be on the same network, right? So, and also you might think of not putting them into the same network. So such cases has become difficult to implement from one central location.
Now, why I ask such question, like in a normal IT environment where internet is available, all these security solutions can be configured with two-factor authentication, where SMS or any login code can be sent along with the password. Okay, but when we talk about OT environment where internet is not connected, configuring two-factor authentication in any of the security application becomes a challenge. So,
Okay. Yes, very valid point.
is there a solution to this problem, or not a problem, kind of environment in which we are working?
Yes, there are standard solution available. You can do it through your domain controller, two-factor authentication. And two-factor authentication can be implemented through multiple ways. One of the two-factor type is you use your username password and then you use your PKI card, or you use your username password and use your biometrics. These are two factors. And for this, you might not require the internet connectivity. You require network connectivity for sure, but you might not require the internet connectivity. Internet connectivity is typically useful when you are sending the OTPs because they are typically done from cloud application and you really need to have access to their APIs. But these kind of solutions are possible as two-factor authentication as well. Use biometric, use PKI RFID-based cards as your second factor. Now, another challenge, you have brought this point, very valid point here, is how do I update my signatures into that central server, which we might use for provisioning the agents into different systems, right? Since it is not connected to internet. That's why in this particular example as well, we have put up some of the server in the DMZ, and one of them is the patch management server. So from this patch management server in DMZ is basically connected to the internet through the firewall, and you will download those patches here. And from this DMZ system, you will be sending it to your systems down the stream. So you can use some different system as a broker service here, where you will again download this patches from your DMZ to your site level central PC. In Siemens terminology, it's called service PC. From service PC, you would basically will be provisioning all those updates to your different servers that you are using.
Now, one more thing, like whenever some data goes out of OT environment to any of the IT systems, say if Pi is there, so we need to have some standard username and password on both sides. Not standard, any username and password configured with the same details on both of the sites to operate these DCOM services. So how is this challenge overcome? Like if say I'm in OT environment and someone else is in IT environment, I prefer not to change that password, that remains same, because that at the same time won't be changed in the IT environment frequently. Because if I again and again, that is done only at the time of configuration of the first time configuration. Mostly everybody might be as of now doing the same way. Like when the first time it is configured, whatever username is there on the OT system will be made on the IT system as well, whichever is interfacing to the OT system, and that will be kept that way, not changed until the system itself is changed. So since many people of the same domain are connected, how we are taking this thing. This is one kind of vulnerability that we are keeping open in the system, like one password for
Yes.
longer duration.
Yes. So you might recall the Friday's discussion that we had type of vulnerability. One of them is about policies and procedures, right? And this is a typical example of your procedural vulnerability, that you are not setting the guidelines to change your password frequently. This is one case. Second case is you're also allowing to reuse the passwords at two different locations, right? So again, this is a problem of procedure, and it has an inherent risk in this procedure. Organizations should do this due risk assessment and provide for the technologies that will mitigate the risk. Sometimes it is challenging to implement the technology because in your personal system, the system would not allow you to use your last three passwords, right? And same thing can also be used for Pi server because they will typically also will work on Windows system. And when you log into Windows, it should not allow you to use your same password at both sides. So that's one case. And second case is don't use your system directly connected to both the networks. There should be a broker server in between through which you are getting the access to. If you are using two different networks into same system, then it's basically not giving you any security mechanism between two different networks. You are merging these two different networks. If one of the network gets compromised, basically the other network is also compromised. Did I lost you?
No. The question was a bit different, though architectures are there and there is no such thing like two networks on a single system. Architectures are well thought of, designed and implemented. The thing was of implementation of OPC communication, and this is one problem that might be persisting everywhere. And since
Absolutely,
people from
absolutely.
IT is also here, so my point of discussion is that through some IT system, is it possible to have some kind of script that means we have to make things simple so that it would be easy for everyone to execute. If the
Okay, so
things are
I'll give you an example. You rightly mentioned that. In one of the system that I worked 4 years ago, they had this challenge that their network devices did not have the capability to automatically prompt for password expiry. And since they have to comply with the 1 year password change policy, what they had done is they had a SIEM solution, and SIEM will be giving you alert. So they configured an event in Windows that after 1 year of expiry, that event will be generated, and this event will go to SIEM. And until that event is closed, it will continuously will be solving. So it basically thinking out of the box to mitigate that risk that might be there of not changing the passwords of network switches after 1 year. So similar way, you can also put up something like this, that the event triggers maybe somewhere in your corporate side of the world. And if the people are not taking action on that event, it will still be the open ticket over there. You go and change your password after the frequency of the time.
okay. Thank you.
Any other question?
Sir, can you explain like why IPS is not recommended for OT system in detail?
Okay. So the typical difference between an IDS and IPS is the capability to basically stop the traffic moving from that particular one location to another location. And that's the one reason that you don't want to use IPS at those layer 2 and below. The operations are more important. They will take precedence over your security. And that's why we want to know what is the malicious activity that might be present at the plant, but we don't want to stop it until it is 100% sure, because IPS might have false positive, and if the false positive is there and the packet is dropped, then there could be some action that is happening on the device. That's why, because of that low confidence, we don't want to put IPS. Let's take an example that your system is not behaving properly and SIS system is taking an action to block that particular flow of liquid, maybe in one of the plant, or maybe take action on breaking the circuit somewhere. And if you block that particular packet using IPS, it might be devastating for the grid. That's why we don't want to put IPS in the layer 2 and below, even layer 3 as well in industrial control systems. Is that answer your question?
Yeah. Thanks.
It's basically a more of the confidence that you have in the system. And since those kind of signatures are not very well known about the ICS system, we might not know that one of the event that triggers only once in a month. IDS will simply generate alert, okay, this is the event that is happening this month. It was not there. But IPS might block that event. And that might be important for you. Okay, so any other question?
Shiv, can you please come to the Purdue model architecture, please? So here, my question is for substation level, layer 1, 2, and 3 up to okay up to this 3 layer 3, we are at substation. 3.5 is for DMZ. But if we talk about the multiple substation and with the center environment, so how do my syslog should travel?
So are you seeing a different screen that I'm seeing, sharing now?
Right now we are with grid control level.
Yeah. Is this visible now?
Yes.
So this is the document that I was talking, and you were talking about this log server, right? This is with the CCAM to protect devices, but the concepts can be any way could be used for any substation system for that. Any provider irrespective of Siemens. The question was related to your syslog
Syslog.
servers, right?
Right.
So here in this architecture, what we have kept is the logging server again. This is the different logging mechanism. This text talks about backup and restore though. So all of these layers, they would be having a logging server available in the station level. And this logging server can send data to your control center as well. This is why also I'm shown here. If you want the same capability to be replicated at the control center level, you can forward this log from your logging server to your control center as well. And why we want to keep it separate? Because this control center to substation level, you require a VPN-based connection. Because they might be at two different physical locations altogether. They are not into same premise. That's why you need to configure a VPN. Through the VPN, you can take it from your logging server. All of them are in the DMZs. That's how you get the data from your different substations to your control center.
So here I will add to my question. In substation level also we do have the DMZ. At control center level also we are having DMZ. Information from substation level will be not directly will be on one of our protocol, and this syslog will be transferred to SIEM and it will be common for substation and central control center. So it is not part of control center.
Yeah, it's basically in this architecture, it's this logging server is part of your substation. That's why it says substation level. And this can send the information either to SIEM or your control center level. Both of the combination are possible. And even it can send to both the locations as well. Sometimes I have seen people putting SIEM in the substation itself. That is also possible. It can also forward. The best thing if you are having your SIEM at the control center level, you aggregate the log as a log server at this control center from all the substation. And from that logging server, you send the information to your SIEM.
Do we have any means based on the experience or means past configurations, how much bandwidth it will be required if I want to collect syslog from a approximately you have said that 10 equipment like server and firewall and switches. So if I consider all the 10 devices, what would be the bandwidth requirement for that log in a typical environment?
So it depends on what kind of network you are having, but bandwidth requirement is very less for sure. Just 5 equipments, how much traffic it will generate, few MBs of data, maybe 100 MB of data, 200 MB of data. That kind of logs you can actually forward to the control center using the standard network connectivity that is available today. If you're having a lease circuit, it will typically be 400 MB, 500 MB of the capacity now, right? Sometimes it goes to Gbps as well. Or if you're having internet connectivity also, it can be forwarded through VPN.
Okay, thank you.
So I pasted the link to this document. This might help you basically combining the learning across different areas. And the title itself is put up into the different segment of security that you are learning. How do you start with secure architecture, hardening of the system, access control, logging requirement, patching requirement. Patching is also very important. How do you patch from your corporate side to your substation side? How do you bring the WSUS log or your antivirus updates to your substation?
Yes, please share this document. Will be very useful.
Yeah, I have pasted the link of this document already, but yeah, I think that is in the chat box. Okay, so if no further question, we can close. This is what I had for today. Akshay, are you there? Somebody from CBI.
Close the session for today. the participants are having more questions, then we can continue. Are there any more questions to Shiv sir? I think, sir, we can close